In the we have studied about the properties of alcohols and phenols in the previous video. The continuation part of these properties will be studied under this video or in this session. The chemical properties. In the chemical properties of alcohols and phenol, there are three different properties are discussed. The reaction towards the hydrogen halides, reaction with hydrogen halides, how alcohols and phenols react with the hydrogen halides, and how alcohols and phenols react with the dehydration or sulfuric acid. With sulfuric acid, dehydrating agent, concentrated sulfuric acid. When concentrated sulfuric acid is treated with the alcohols and phenols, they undergo dehydration. How dehydration takes place and what is the mechanism of the reaction? That part we were discussed in the previous video. In this video, the continuation part of chemical property, the dehydration. In the dehydration, we observe one important thing. The important thing of dehydration is what is the tendency or what is the order of the alcohols towards this process or dehydration process. Okay, what is the order of dehydration of alcohol? The order depends upon the degree of the alcohol. If we consider the primary alcohols are denoted as RCH2OH. Okay, this is the primary alcohol. The primary alcohol, in case of primary alcohols, the OH attached carbon contains only one R group. Hence, electron donating nature is less. When electron donating nature is less or electron deficiency compared to other degree of alcohol, this carbon possesses a less number of or electron deficiency. It possesses electron deficiency because electron donating nature is less. Hence, the donation of OH or the removal of OH becomes little bit difficult. Hence, this does not show more tendency towards the dehydration. In the previous video, I am considering the primary alcohol that undergo dehydration and produce alkene. Okay, just I recall once again. In the previous video, we will consider one alcohol that is propanol CH2OH. This is the propanol. The propanol undergo, suppose, okay, consider propanol CH2CH. Okay, when propanol undergo dehydration, it produces propene. Okay, or CH3CH2OH. What is the name of this compound? Ethanol. Ethanol undergo dehydration with concentrated sulfuric acid. It produces ethene. These parts are discussed in the previous video. So in these things, the alcohols are primary. These are primary alcohols. Primary alcohols shows less tendency. Why? Because electron donating nature or R group, only one R group is attached and others are hydrogens. OH attached carbon contains hydrogen. Okay. Suppose we consider secondary alcohol RCOH. How it becomes secondary? Or when it becomes secondary, OH attached carbon contains one hydrogen, two alkyl groups. This is the secondary alcohol. Secondary alcohol. In case of secondary alcohol, how many electron donating groups are attached? 1, 2. 2 electron donating. More electron donating. Carbon contains more electron, hence carbon is electron rich. When carbon is electron rich, they have tendency to donate OH. The increases, tendency of donation of OH is increases. Okay. Suppose you consider tertiary R dash, R double dash, OH. Suppose we consider tertiary alcohol, then all groups are alkyl groups. Alkyl group shows a tendency of donation of electron donating groups. Because of that, carbon OH attached carbon become more electron rich, hence OH group is easily liberated. The tendency of leaving OH group is more in case of tertiary alcohol, and next is secondary, next to primary. Where there is more tendency of leaving OH group, that alcohol shows more tendency of dehydration. What is the conclusion? Conclusion is the order of dehydration is tertiary, next secondary, next primary alcohols. Okay, this is very important part for your competitive exams or in your theory. Though it is a very important things under 1 marks questions. Okay, next, because of this order, we can change the reagent for the dehydration purpose. Okay, what is the suitable reagent for the dehydration? In the previous video or previous session, we have discussed the same thing, dehydration, and consider primary. For primary alcohol, we need more or strong dehydrating agent. The strong dehydrating agent is concentrated sulfuric acid. Therefore, R CH2 OH. This is the primary alcohol. For this case, to dehydrate the alcohol using concentrated sulfuric acid, around more than 443 Kelvin is required. More temperature is required. When temperature increases, concentration of sulfuric acid is increases, and it gives gives a corresponding alkene. Okay, so alkene is produced. Corresponding alkene is produced. For secondary, okay, you consider an example. Better to consider an example. CH3, CH2, then it becomes CH2, CH2. Okay, ethene is produced. For primary, we need concentrated sulfuric acid at a higher temperature. In case of secondary alcohol, we need phosphoric acid around 424 Kelvin temperature. Small amount of temperature is enough, and only 80%. What do you mean by 80% of phosphoric acid? Other 20% is water. Okay, diluted. Small quantity of water is added to make 100%. Then gives CH3. How? Between this carbon, one hydrogen eliminated. CH double bond CH2. Hydrogen of this, OH of this eliminated. Okay, water is eliminated. This is the product. And in case of tertiary, CH3, okay, CH3, CH3, CH3. Okay. The common name of this is tertiary butanol, or 2. The second carbon contains methyl and OH, therefore 2-methyl propanol, propane 2-ol. Okay. This is when this product or compound is subjected to dehydration, we need a mild reducing agent, mild dehydrating agent. Okay, mild dehydrating agent is enough to dehydrating this one. Again, phosphoric acid around 20%. What do you mean by 20%? 80% to 20%? Only 20% phosphoric acid, and other thing is water. Okay, and temperature is small quantity of temperature is enough. Around 380 to 400 Kelvin is enough. And CH3 between any one carbon, okay, double bond is generated. Okay, consider the same thing. Carbon between these two carbon and the CH3. This is the product. Okay, try to name these two product. Okay, this is the work for you. And this is the order. Also, what it concludes: primary needs strong reducing agent, dehydrating agent. Secondary need less reducing agent. Mild reducing, dehydrating agent is enough. Mild dehydrating agent is enough to dehydrate the tertiary alcohol. So therefore, what is the indication? Tertiary has more tendency, and then secondary, next primary. So this is the order of dehydration. Okay. Next. The other chemical property, the third or fourth chemical property, that is oxidation. Okay. Oxidation property. Oxidation of what? Oxidation of alcohols. Okay. Oxidation of alcohol. In case of oxidation, what type of reaction it is and how oxidation take place? The oxidation take place in the form of removal of hydrogen from the alcohol. So when removal of hydrogen take place in the alcohol, the process is oxidation. And what is the product? What is the product form? Okay, I am consider primary again. Primary alcohol COH. OH attached to carbon and there is one R group, and others are hydrogen. For the purpose of oxidation, we need oxidizing agents. Correct? Then what are the oxidizing agents? I am told about the oxidation and reduction. Please list out the all oxidizing agents and reducing agents, and you observe what are the strong oxidizing agent and what are the strong reducing agent, and what is the role of that oxidizing agent when it is required, for what purpose. What purpose the oxidizing agent is used, and what are which oxidizing agent is necessary for the reaction, for a given reaction. Okay, so this is a very important thing for your exam point of view also, as well as for your competitive exam point of view, or your knowledge point of view also. These things are very important. First, list out the few oxidizing agents and few reducing agents. In case of alcohol, depending upon the degree of the alcohol, depending upon the nature of the alcohol, we need different oxidizing agents. Strong reducing agent is required in few cases, and in few cases mild reducing agent is enough. Okay, so in case of, I am considering general cases, I am considering primary alcohol. This is the primary alcohol. How can you identify the primary alcohol? OH attached carbon contains only one alkyl group. Okay, this is the primary alcohol. When primary alcohol is subjected to oxidation, okay, I don't consider any oxidizing agents. Any oxidizing agent. Suppose we use any oxidizing agent, and what is the process taking place under oxidation? The basic things, please understand the concept of oxidation. Then the whole thing become easy. It loses its hydrogen. When it loses hydrogen, the new bond generated between these oxygen and carbon. Because of that, another hydrogen also eliminated. How many hydrogen is eliminated? Okay. What is the reaction? Cleavage of oxygen, hydrogen bond, correct. Next, cleavage of carbon and hydrogen. Okay. So that the reaction take place. In these cases, removal of hydrogen. Yes, removal of hydrogen, therefore it is oxidation. Removal of H2, then therefore it is also known as not dehydration. It is not removal of water molecule, it is a removal of hydrogen. Therefore it is dehydration. Okay, dehydration. Sorry, dehydrogenation. Hydrogenation. Okay, this is the dehydrogenation, not dehydration. It is dehydrogenation because of removal of hydrogen. So then, what is the product? I think all of you are able to identify the product RC. Okay, one hydrogen and one hydrogen is eliminated. Carbon contains one R and H. Okay, this contains H, and there is a double bond between this carbon and oxygen. Then what type of product it is? It is nothing but aldehyde. Okay. Then what is the conclusion? When alcohols are subjected to oxidation, it gives corresponding aldehydes. It gives corresponding aldehydes. The next thing is, depending upon the oxidizing agent, again it undergo oxidation, gives, okay, depending upon the oxidizing agent. Suppose we use strong oxidizing agent, then it again gives oxygen. When it takes again oxygen, the H become OH, oxygen added. Because of that, aldehyde get converted into carboxylic acid. Carboxylic acid is converted. Carboxylic acid is converted. The very easiest thing. This is the general manner of oxidation of alcohol. Any primary or any alcohol, when it is subjected to oxidation, mainly primary, okay. The secondary, there is another possibility. Tertiary does not show oxidation. Let us now discuss about all the things under this video. First, I am consider primary. When primary alcohol is subjected to oxidation, it produces aldehyde. Depending upon the oxidizing agent, then it gives a carboxylic acid. Suppose it is strong. Oxidizing agent is strong, then it gives a carboxylic acid. Okay, let us discuss the oxidation by considering example of different alcohol as well as different oxidizing agent. And just give the list of oxidizing agents. KMnO4, potassium permanganate, is oxidizing agent in acidic media. It is known as acidified KMnO4. Acidified KMnO4 is the strong oxidizing agent. Okay. Next, another example is anhydrous chromic trioxide. Okay, chromic anhydrous. Name is chromic anhydrous. It's oxidizing agent. Next, PCC. PCC, pyridinium chlorochromate. Chlorinated chromic acid or chromium trioxide dissolved in HCl and as well as a pyridine. Okay, then it is pyridinium chlorochromate, PCC. It is the another oxidizing agent. Copper metal around more than 573 Kelvin. Other conditions are required. What is the need of that condition? More efficient. KMnO4 is more efficient oxidizing agent in acidic media. Copper is more efficient, shows more efficiency around more than 573 Kelvin. And the chromic anhydrous in pyridinium and HCl, it shows more efficiency. Therefore, it is known as this one. We use the media in the condition because of the efficiency. Okay, let us discuss about the oxidation of alcohol using different oxidizing agents. When KMnO4 is used as an oxidizing agent, in case of primary alcohol, suppose primary alcohol is subjected to oxidation with the help of KMnO4, acidified KMnO4, then what is the product? Primary alcohol was produced corresponding aldehyde after it produced carboxylic acid. What is the reason? The reason of this reaction is KMnO4 is strong oxidizing agent. KMnO4 is strong oxidizing agent. Therefore, primary alcohol get converted into aldehyde. Along with that, it produces a carboxylic acid. The reason is it is strong. First use few quantity of oxygen, alcohol get converted into aldehyde, and again use oxygen, therefore it got converted into carboxylic acid. Okay, I think it become very easy. Please remember in this manner, where it is very helpful for your exam. Okay, the next is when primary alcohol is subjected, or our intention or your intention is produced to only aldehyde or to isolate the aldehyde, we use anhydrous chromic trioxide. Okay, this is the anhydrous media because of that it shows more stability and more efficient in anhydrous media. Primary alcohol is subjected to this, then it produces aldehyde. Okay, let us discuss about these two things by taking the example. I am considered primary alcohol CH3 CH2 OH. Okay, CH3 CH2 OH. What is the name of the compound? 2 carbon 8 enol. Okay, ethanol. When ethanol is made to react with acidified KMnO4. Okay, acidified KMnO4, ethanol in acidified KMnO4. But what type of reaction it is? Primary alcohol in presence of KMnO4. First it produces aldehyde, along with it produces carboxylic acid. Okay, next CH3 CHO. Confused it? Okay, I am explaining the things. How this product is formed? CH3 CH2OH. H of alcohol 1 and another H of carbon eliminated. Okay, dehydrogenation take place. CHO remains. CHO. Okay, aldehyde is produced. So what is the name of the aldehyde? Ethanol is produced. Okay, ethanol not remains as ethanol because of the acidified KMnO4 again undergo oxidation. And produce corresponding carboxylic acid CH3COOH. Ethanoic acid is produced. Okay, please remember these things, very important. Ethanol gives ethanol, and then it will undergo oxidation produce ethanoic acid. Okay, I think it become easy now. Ethanol, in case of exam, there is a possibility of asking produce or how to prepare ethanoic acid from ethanol. What is the process? using KMnO4 in acidic medium. Okay, so this is the reaction. Very important. All oxidation reactions are important. It is very helpful in case of in case of the competitive or in the theory exams. Okay, and consider the next oxidizing agent. Okay, just I wrote the oxidizing agent here. Here I am using chromic anhydrous. Then it produce only ethanol. Only ethanol. Again, oxidation does not take place. Okay, so this is the process of oxidation. Okay, by considering other oxidizing agent, what happened other oxidizing agent? Suppose we consider PCC. In case of pyridinium chlorochromate, and consider one alcohol contains double bond CH, double bond CH, correct? CH2 OH. Okay, what is the name of the compound? Please, anybody tries to fill the name of the compound? 1, 2, 3, 4. 4 but, 1 contains alcohol, 2 contains double butene. But here 1, 2, second one contains butene, 1-ol or butanol. Butanol. When butanol is subjected to oxidation, oxidizing agent is PCC. Suppose PCC, then it produces aldehyde. Okay, it produces aldehyde. CH3, double bond remains. Okay, please remember, double bond remains as double bond, and it produces corresponding aldehyde. What is the name of the compound? Al-but-2-enol. But-2-enol. Okay, or any primary alcohol. Please remember that any primary alcohol subjected to oxidation in the help of oxidizing agent PCC, then it produces aldehyde. Corresponding aldehydes are produced. Okay. The next is next oxidizing agent is or PCC using different degree of alcohol. Okay, secondary alcohol CH3 CHOH CH3. This is a secondary alcohol. What are the things different? What are the different things observed here? CH3 CH3, 2 R group and 1 hydrogen. In case of primary, this is also hydrogen, correct? Because of that, it produces CH3 CHO. Aldehyde is produced, but in this case there is no H. It is H3 CH3. Because of that, suppose we use PCC as an oxidizing agent, then secondary alcohol. What is the name of this secondary alcohol? And consider an example. Secondary alcohol CH3 CH3 CH3. It is isopropyl alcohol, or better to call it as propyl alcohol, or what is the iodide name? 1, 2, 3. Propane to all, subjected to oxidation with the help of PCC, then it produces corresponding. Okay, what happened in this case? H of this and H of the carbon, secondary carbon, eliminated, correct? So hydrogen eliminated out, dehydration take place, and acetone is produced. Acetone is a type of ketone. Okay, what is the conclusion? What is the conclusion of this reaction? Suppose the secondary alcohol undergo oxidation, it gives corresponding ketones. Primary alcohol gives aldehyde, secondary alcohol gives ketone. Tertiary, in case of tertiary alcohol, what is the difference observed in the tertiary alcohol? CH3 CH3, CH3. There is no hydrogen. Please observe. On the tertiary carbon, there is no hydrogen. Therefore, we use KMnO4 or K2Cr2O7. Any oxidizing agent not capable to oxidize the tertiary alcohol into aldehydes or ketones or carboxylic acid. The reason is carbon, OH attached carbon is known as alpha carbon. Alpha carbon does not contain any hydrogen. There is absence of alpha hydrogen. Okay, alpha hydrogen is absent. Because of that, oxidation is not observed. Okay, this is the important thing. Primary gives aldehyde, secondary gives ketone, tertiary does not produce aldehyde, ketone or carboxylic acid. To produce carboxylic acid from alcohol, we need strong oxidizing agent. Okay, so this is about oxidation. The another oxidizing agent, copper is also used. Okay, copper around 573 Kelvin. When primary alcohol is subjected to oxidation, copper around 573 Kelvin, then it produces CH3, CHO, okay, alcohol, aldehyde, and CH3, CH2, OH, and consider it as made as a secondary. Okay, what is the name? Ethanol produce ethanol. Okay, it's the first case. In the second case, what is the name? Isopropyl alcohol produce, in case of copper around 573 Kelvin, it produces acetone, CH3, CH3. Acetone. Okay. It is the other example of oxidation. Okay. Please remember all these things. There is a confusion arises during the exam. Suppose in case of in your exam, it is a given ethanol to ethanol, there is a question mark on the error mark. What is the correct answer? You can use the PCC or you can use the copper. Any one oxidizing agent. These oxidizing agent shows same role in case of oxidation. Correct? Next, these are about the chemical properties of alcohol. The last part of this session is chemical properties of phenol. And consider few chemical property and other chemical property will be discussed in the next video. The first chemical property of phenol, okay, is chemical properties of phenols. Is the very easiest chemical property, and I think all of you well known about these chemical property. These are electrophilic substitution reaction. Okay, electrophilic substitution reaction. Electrophilic substitution reaction. The electrophilic substitution reactions are I think all of you are well known about electrophilic substitution reaction of benzene. Similarly, electrophilic substitution of phenol take place. The first electrophilic substitution reaction is can anybody give the electrophilic substitution reactions? The first electrophilic substitution reaction is halogenation. Okay, halogenation of phenol. What are the electrophilic substitution reactions? There are four important electrophilic substitution reactions: halogenation, nitration, sulfonation, and Friedel-Crafts alkylation and acylation. Okay, so the first is halogenation. Halogenation of phenol. When phenol is subjected to halogenation, depending upon the halogen, it produces a product. Okay, in case of halogenation, I am consider chlorination. When phenol is subjected to chlorination, it produces. For that purpose, we need anhydrous aluminum chloride. Correct? For the chlorination purpose, we need anhydrous aluminum chloride. Then it produces alcohol remains as or OH remains on the first carbon, and other is substituted by electrophilic substitution. Chlorine undergo generation of electrophile and attack on what? Attack on which position of the base. Then that is the important thing. In case of phenol, it contains OH group. OH is electron dominating group. Hence, electron clearly observed. Okay, electron OH is electron dominating group. When OH dominate electron, this pi bond shifted on the ortho position negative. In the next case, it undergo formation of new bond. After formation of new bond, this pi bond shift on the para position. The negative charge moves towards the para position, next again ortho position. So these things are observed in the first year. The electron donating nature or EDG creates electron rich center on ortho and para position, or in easiest way, OH group is ortho para directing group for electrophilic substitution. For electrophilic substitution, or electrophile is the incoming reagent, then OH group give the position of ortho and para. Because of that, it produce one product is orthochlorophenol, and another one is parachlorophenol. Okay, ortho product, para. In the similar way, bromination, Br2, then it produce orthochromophenol, parachromopenol. This is the very easiest thing, I think. Next is depending upon the quantity. Okay, the next thing is depending upon the quantity. Suppose we use excess quantity of bromine, then there is a difference. What happens in case of excess quantity of bromine is considered for the reaction. Suppose 3 bromine is taken, excess quantity of bromine is taken. Please remember the differences. Okay. In the small quantity of bromine, it produces ortho and para position, para product. In case of excess quantity of bromine is considered the reaction, then it produces, what is the name of the product? 2, 4, 2, 3, 4, 5, 6, 2, 4, 6, tri, bromo, phenol. Okay. This is a phenol that is 3 bromine. Okay, another type of reaction. Next, second type of reaction is nitration. Okay, electrophilic substitution. Another type of electrophilic substitution reaction is nitration of phenol. What happens in the case of nitration of phenol? Or better considered as B. Okay, A is halogenation, B is nitration. For the nitration, we need concentrated nitric acid. Concentrated nitric acid HNO3 and concentrated sulfuric acid H2SO4. Okay, please remember the very important thing it is when phenol is subjected to nitration, what is the electrophile generated from nitric acid and phosphoric acid? It is NO2 plus nitronium ion is generated. The nitronium ion is the incoming electrophile, attack on ortho nitrophenol plus para nitrophenols are produced. Para-nitrophenols are produced. Here, one is ortho-nitrophenol, another one is para-nitrophenol. Then then which one is the major and which one is the more stable? Here there is a difference. In case of chlorination and bromination, the para-bromo or para-chlorophenol is more stable. Here, nitrate group is on para position, ortho position, and creates hydrogen bond. There is a possibility of formation of hydrogen bond. What type of hydrogen bond? Hydrogen bond is formed in the same molecule. It is intra hydrogen bonding is observed. Because of that, it is more stable and more quantity of ortho is generated. 50% of ortho, nearly okay. 50% of ortho, 50% of para. And there is one difference and in the product when we use excess quantity of nitric acid. Suppose we use excess quantity of nitric acid, clearly observe, excess quantity of nitric acid. Excess HNO3 is used, then all the possible positions are ortho, para. Ortho position is here, ortho position, para here, sorry, N2. As similar as that of bromination, this is the nitration. Excess quantity of nitric acid is used in the reaction, then it produces 2, 4, 6 trinitrophenol. The common name of this compound is picric acid. Okay, picric acid. Please remember this thing. Okay, picric acid. Common name is picric acid. Why it is important? There is a possibility of asking the question on this part. Prepare picric acid from phenol. Give the chemical reaction or explain the process of preparation of picric acid and all that. And the next reaction is B. Next C is sulfonation. And the next D is alkylation and acylation. Alkylation and acylation, sulfonation is not much important. Therefore, I am leaving it to B. Okay, this is the homework for you. Please try to identify the product of sulfonation of phenol, alkylation of phenol, and acylation of phenol. Okay, and the important part is nitration. Here, phenol is treated with excess nitric acid, then it produces picric acid. I think it is a new thing. Therefore, it is very important. And other important things are oxidation. Okay, please once again I explain the oxidation. Oxidation is depend upon the oxidizing agent, okay, and the nature of the alcohol. Please list out the oxidizing agents. What are the strong oxidizing agents? What are the mild oxidizing agent, and differentiate these two, and what is the role of the oxidizing agent. Okay, these things are very important. The very basic things for your higher study also. And stop the video here, and in the next session we will discuss about the other chemical properties of phenol, the very important reaction, Colway's reaction and RT reaction. These two parts will be discussed in the next video. Thank you for watching.